welcome back again. Let's talk about the thinking pathway for multiplication strategies. So, this one, of course, mirrors what we did with addition, only now we're thinking in groups of. So, with multiplication, we're thinking of switch, predict, plan, and solve. So, switch, when we're multiplying, you can multiply in any order and the total's still the same. There is one important distinction here, though, is that with multiplication, when you switch, you're switching which number is the multiplier and which one is the number of items in the group. The multiplicand is the old-fashioned word. And so when we switch, if there's any context, we have to realize that that switch is still getting us the same amount, but it doesn't behave the same way, right? We talked about that in the last one. 9 times 3 and 3 times 9. If my doctor gives me some pills and he tells me to take 3 pills a day for 9 days, that is not the same as taking 9 pills a day for 3 days, even though the total is 27. So keep that in mind when we're doing switching with multiplication. But when we're talking about facts, the kids can decide, okay, which one would it be easier for me to focus on? Which one would be easier for me to think of as the groups and which the group size, and which one would be easier for me to think of with the number of groups, right? The multiplier. So I can switch, then I can predict how large or small is this going to be, and then make a plan and solve. So these are the strategies that we discussed in the last workshop, and we're going to just take these one at a time and talk about how that learning pathway might help us. So first off, I just have some manipulatives here. You just as a reminder that when we're working with multiplication, we have to be thinking of groups, right? So here I just made 10 stacks of 4, 10 groups of 4 to help me with my explanations. You can use any manipulative you choose, but just remember that you have to be really clear about which is the multiplier and which is the quantity being multiplied when you're working with your multiplication facts. So first, let's just take a look at the identity property. The identity property is just when you're multiplying by 1. And so we want the kids to be able to think that 4 groups of 1 and 1 group of 4. So 4 groups of 1 would actually really look like this, right? Here I have 4 groups, 4 stacks, and there's 1 on each stack, as opposed to 1 group of 4, which would look like this, right? This is 1 group of 4. This is 4 groups of 1. In either case, that 1 being the identity element, it actually shows that you still have 4 either way. Either you have 4 individual items or you have a group of 4. So that's what we want our students to become really familiar with. So that's why we want to first have them take a look with that thinking pathway. Are we going to switch? Does that make a difference in how I think about it? Then I'm going to make a prediction, how large or small, how many times larger is it going to be? And then plan and solve. So the next one we're going to take a look at is this idea of repeated addition and using skip counting. So with repeated addition and skip counting, honestly, this is often our times 5s, our times 10s, sometimes our times 2s. We can also think the 5 times, the 10 times, the 2 times. Although I think there's a big distinction between, especially this one, because times 2 kind of sounds like I'm skip counting by 2s. Whereas when I'm doing 2 times something, this one is really the idea of doubling, right? If I have 2 times 8, it's double 8. 2 times 4 is double 4. And that will probably get me further as I move on down the road. But the reason I bring this up is this is where it's easiest for our kids to really lean into that idea of repeated addition and using their skip counting. So 5s, 10s, and 2s, they've been working on those since they were in first grade, sometimes even kindergarten. Now, you can also use skip counting with something like 4s. I use a lot of songs like I use jingle bells for the 3s and 4s. So here I have the 4s, so it would be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So you can teach the kids to skip count, but know that that's like the lowest level of the mental strategies, right? We want to go from skip counting, moving into strategic thinking and mental math, and then into automaticity. But know that that's a possibility, right? We have all of that. But with 5s, 10s, and 2s, that it's really helpful for the kids to lean into their skip counting. So just knowing that you have that. And often we want to think of the 2 times facts as doubling, much like we did with addition, right? The double 2, double 8, double 4, when you're adding 2 of them together. So since we're talking about doubling, let's just jump into this idea of using doubles. So when I'm starting to use these mental math strategies, I'm once again going to think into switch. Which one do I really want to focus on? And then predict how many times bigger is this going to get? And then to make a plan and solve. So when I'm using doubles, this is really the 2 times, the 4 times, and the 8 times, right? So if I'm going to do doubling, like let's say I have 2 times 4, right? That's going to be double 4. So I can just take all these off and see that that is double 4, right? 2 times 4 is double 4, 2 stacks of 4. Then when I have 4 times 4, that's double double. So I had 2 times 4 gave me 8. And now I'm going to do 4 times 4, which I doubled 4, then I doubled 4 again. So 8 and 8 is 16. If I have 8 times something, let's do 8 times 4 here. So the first time I doubled 4 for 2 times 4. And then for 4 times 4, I did double 4. And now I'm going to double that one more time for 8 times 4. So double 4 was 8, double double was 16, double 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 gets me to 32. 4, 8, 12, 16, 20, 24, 28, 32. Right, I can go back to skip counting as well. But this whole idea of using doubling, first off, it's just it can be very game-like. And in the next session, we're going to talk about some of the games you can play to help get the kids working with their fluency. But just using this idea of doubles, and when you get into division, the halves can be really helpful for your kids. Now, this idea of add a group and subtract a group, the same thing applies. We're going to think about adding a group. So let's say we have 6 times 4. So if I have 6 times 4, that means I have 6 stacks of 4, right? If I had written it as 4 times 6, I could have thought of would I rather look at 4 times 6 or 6 times 4? I think I would rather add a group of 4. That's easier for me to think about. So with 6 times 4, I'm going to think 5 times 4 is 20, and another 4 gives me 24, right? So I just added a group on. As opposed to if I have 4 times 4, subtract a group, I would start with 5 times 4 and then take one of those 4's off to get me from 20 to 16. So add a group, subtract a group. Once again, we're going to decide which way do we want to look at. Do we want to look at the groups of 4, 6 times, or the groups of 6, 4 times, which is easier for me to think about. And then how do I want to do it? Can I use add a group or subtract a group to help me? And then finally, this idea of break apart. This is probably my favorite way to think about multiplication facts, especially the facts that aren't like at the tip of my tongue. Like I know 5 times 4, right? I know 5 times 4 is 20. So what if I have 7 times 4? Here I have 7 times 4, right? 7 stacks of 4. I can break that 7 apart into 5 and 2. So I can see that 5 times 4 is 20, and 2 times 4 is 8. So altogether, that's 28. So if I was using the thinking pathway, first I would want to think, do I want to switch? Would I rather think of 7 times 4 or 4 times 7? Then I'm going to predict, if I want to have 7 times as many of 4, or do I want to have 4 times as many of 7? So I'm obviously getting larger. And then I can make the plan here. I chose to use the break apart strategy. So that's the thinking pathway for multiplication. Join me in the next video to chat about how we're going to use those ideas to help us with the thinking pathway for division. This was multiplication. Now we're moving into division.